Hello everyone, this is Daniel. I'm going to show you today how to develop VST plugins using JRuby. Our project is called Opaz PlugDK. It was originally started by Thibaut and then later joined by me. Opaz PlugDK allows you to develop VST plugins Ruby style. That is, we use a dynamic language to produce real-time audio. Opaz PlugDK is based on JVST wrapper and uses JRuby as the Ruby interpreter. Some of the features that we have is, for instance, a one-command Rake task that allows you to generate a VST plugin for all three platforms, Windows, Linux and Mac OSX. We also have a declarative syntax for VST parameter handling, and that avoids a lot of boilerplate code that is usually needed when you develop VST plugins in C++. You can also mix and match Java and Ruby code, and that by either calling Java static methods or by using the Java inline Ruby gem. You can attach JRuby to your plugin and then hack into the plugin to change parameters, for instance, or randomize parameter values. And also, the plugin itself is reloaded when the source file changes. And this is one of the features that we use extensively in the hands-on session that now follows. Alright, let's get started. I'm going to show you now how to install Opaz PlugDK and then how to use it for plugin development. As you can see, I've already cloned our Git repository just because I don't want to bore you with staring at the Git screen and then waiting until it's finished. Alright, let's change directories and then use Rake to generate binaries for each platform. Let's check out what Rake has generated. So we go to the plugins directory and then to simple plugin, which is the plugin that we generated using the Rake task before, and then to the build directory, and then we can see the three directories for each of the target platforms. We will now open the plugin in a VST host application. We are now going to open the log file of the plugin. Then open its source code. The plugin consists of two classes, the GUI class and the class that contains the audio algorithm. Now while the plugin is running and producing audio, let's change the gain parameter. Notice the significantly lower volume level. The plugin has been reloaded and this is also reported in the log file. Let's do it again. Now let's change the algorithm in a more dramatic way. I have prepared a two-pole low-pass filter that I'm now copying to the currently running plugin. Note that this algorithm has 4 instead of just 1 parameters: cutoff, resonance, and then fine-tune of cutoff and resonance. Notice the sound changes when I save my Ruby file. Again, let's play with the parameters. Now you may ask, what happens if I introduce a syntax error into the Ruby file? The error will be reported in a pop-up window and also in the log file. Let's fix it again. That concludes the first part of this demo. We've started out with a gain plugin and then changed it while it was running to a 2-pole low-pass filter with 4 instead of just 1 parameters. We will now use JRuby to script the running plugin, and then again using JRuby we will create a nice little Java GUI for it. So let's open the GUI of our plugin that includes JRuby and an empty GUI window. We will now access the cutoff parameter of our plugin by using the attached JRuby session. Now let's automate this by creating a loop that opens the filter by 10% each second. We are now assigning a random value to each of the 4 parameters of our plugin. Now let's start working on a GUI. First of all, we're going to change the layout manager of our frame, and then we load the knob widget that we're going to use. Now we create the first knob with a name cutoff that is going to represent the first parameter of our plugin. We add the knob to the frame, create a change listener for it, register the change listener, and then update the GUI. Now let's do the same for the remaining 3 parameters. We now use the attached JRuby session to automate the GUI. We now use JRuby to randomize the value of each parameter. Watch the knobs and their values jumping back and forth. We will now go back to the algorithm of our plugin and add a volume parameter. The plugin is reloaded when I hit Ctrl S. And we can now go back to JRuby and add a GUI element for the volume parameter. We now dump our IP session to a file so that we can replay it later or use it directly in our plugin code. Here is the resulting file. Alright, this ends this demo. We have started with a simple gain plugin, changed it to a filter and added a GUI, and all that while the plugin was running and producing audio. In fact, it is still producing audio. Thanks for watching.